An atom consists of a positively charged nucleus, around which negatively charged electrons somehow move. I will change this drawing, and the electrons are located on this semicircle. Experiments show that some electrons are attracted to the core more strongly than others. This can be explained by the fact that some electrons are close to the atom's nucleus. Some electrons are further away. The next ones are further away, and so on. Electrons form a kind of layer, and when all electrons are in the same layer, they have approximately the same energy, and these electron layers are called energy levels. I will number the first 4 energy levels. In reality, there may be more levels. And each energy level can only hold a maximum of a certain number of electrons. The first level, closest to the nucleus, can only hold a maximum of 2 electrons. The second energy level can hold a maximum of 8 electrons. And the third energy level can hold a maximum of 18 electrons. The maximum number of electrons in a single energy level can be calculated using the formula, where n is the energy level number. Substitute 4 into this formula. 4 to the power of 2 equals 16. Multiply by 2. The fourth energy level can only hold a maximum of 32 electrons. And the farther the electron is from the nucleus, the higher energy electron has. And it undergoes chemical reactions. The atom will donate high-energy electrons from its last energy level, or gain electrons into its last energy level. Electrons do not always move in spheres or circles, as shown here. The geometric figure that an electron draws when moving is called an orbital. The first, simplest geometric figure along which an electron moves is a sphere. This orbital is denoted by the letter S. The next orbital is a dumbbell-shaped geometric figure along which an electron can move. It is denoted by the letter P. The next orbital is denoted by the letter D, and this geometric figure is in the shape of 2 cross-lying dumbbells. In total, there are 7 types of orbitals. This is how the rest of the orbitals are denoted. For the initial lesson, the first 3 types of orbitals will be enough for us. Each orbital can only hold a maximum of 2 electrons. The same is true for the other types of orbitals. At the first energy level, we can have only 2 electrons. And they will be on one s orbital. At the second energy level, there can be a maximum of only 8 electrons. 2 of them will be on the s orbital, the other 6 will be on the 3p orbitals. At the third energy level, the first 8 electrons will be located in the same way as at the second energy level. But the remaining 10 electrons will be located on 5d orbitals. At the fourth energy level, the first 18 electrons will be located in the same orbitals as at the third level. The remaining 14 electrons, subtract 18 from 32, get 14, will be located on 7f orbitals. So we have considered the structure of the first 4 energy levels. Now let's look at some examples. The atomic number in the periodic table coincides with the number of positively charged protons in the nucleus of an atom. In its normal state, the atom is neutral, so the number of protons will also coincide with the number of electrons, The first 2 electrons will be at the first energy level of the s orbital. Subtracting 2 from 6, the remaining 4 electrons will be at the second energy level and fill the s orbital completely, and the remaining 2 electrons will be distributed among the p orbitals. This is written as follows. The first energy level of the s orbital is 2 electrons, the second energy level of the s orbital is 2 electrons, and the second energy level of the p orbital is 2 electrons. And these 2 electrons will not be on one p orbital, but will be distributed along 2 orbitals. The chlorine atom has 17 electrons. The first 10 electrons will fill the first energy level and the second energy level completely. The remaining 7 electrons will be at the third energy level. And this is how it is written down. The first energy level of the s orbital is 2 electrons. The second energy level of the s orbital is 2 electrons. And the second energy level of the p orbital is 6 electrons. Further, the third energy level of the s orbital is 2 electrons. The third energy level of the p orbital is 5 electrons. Let me repeat. Orbital can only hold a maximum of 2 electrons. The maximum number of electrons for the s orbital is 2. The maximum number of electrons for the p orbitals is 3 times 2. We get 6 electrons. The maximum number of electrons for the d orbitals is 5 times 2. We get 10 electrons. And for the f orbitals, we need to multiply 2 by 7. This is 14. Now I will draw this structure of orbitals as a table. Let's look at the arsenic atom. I open the periodic table. In this table, the row number is the period number, and the number of the period matches the number of energy levels of the atom. The arsenic atom is in period 4, which means it has 4 energy levels. And these little numbers represent the distribution of electrons across energy levels from 1 to 4. In this table, I will number the energy levels from 1 to 4. And I will also write down the types of orbitals. There can be a maximum of 28 electrons at the first 3 energy levels. Arsenic has 33 electrons. Therefore, the first 3 energy levels will be filled with the maximum number of electrons. Subtract 28 from 33. And at the 4th level, we have 5 electrons left. And now I will fill this table with the distribution of electrons, by energy levels and by orbitals. Each electron is represented by a single arrow. And the electrons will fill the orbitals one by one from left to right. At the second energy level, we still have electrons remaining. We also fill the cells from left to right. The third energy level is filled with electrons as much as possible. We also distribute the electrons one by one from left to right. At the 4th energy level, the first 2 electrons will be located on the s orbital. We subtract 2 from 5. And the remaining 3 electrons will be located on separate p orbitals. This is how the orbitals are filled. It's an error, not the correct filling. The correct one is 1 electron at a time from left to right. And now, using this table, I will write down the distribution of electrons. According to energy levels and according to orbitals, I propose to check this record on your own if you find an error. Write in the comments, subscribe to the channel. That's all for today. Bye everyone.